very big in size, it's very costly, and the main problem is you cannot keep a spare transformer just in case something happens to the equipment which is already being used. So I will be focusing on insulation diagnosis of power transformer that are already in use. Okay. Now, because it is related to the application of AI and ML, I will be focusing more on the theory part first, and then I will be going into application with few case studies related to high voltage transmission and power system, power transformer insulation diagram. Now, you can see that if you consider classical analysis, its variable selection is a very important thing. Now, regression, which is basically identifying the underlying characteristics between the data samples, cannot be always applicable because depending on what kind of data you are handling, the complicated relation might not be truly apparent by and may not be possible to approximate the same relationship with a standard equation. We will be seeing an example of it. In this case, we generally go for what is known as a supervisory learning network. Now, by far the most common and the most well-known network that we have is artificial neural network, and we also have certain advancement of that, which you might be knowing, convolutional neural network and bidirectional long short-term memory networks. Now, before we go into the actual application, let's very briefly talk about what neural network is all about. Now, you can consider the advantage of having a neural network by considering the fact that it can basically consider a model without finding the actual relation between the data. So essentially you can train a network and you can identify what the output will be looking like for a given set of input without even trying to formulate a model behind it. That is the whole advantage of using a supervisory learning network. Now, if you consider our normal nervous system, the basic unit of a nervous system is a neuron. Similarly, in case of artificial neural network, we will have a basic unit which is artificial neuron. The mathematical model of an artificial neuron basically looks like this. So these are different weight functions and these are the inputs which are actually coming through the neuron. Now this net J, as you can see from this mathematical part, it's basically dependent on the weighted sum of all the inputs that are coming over here, and you have another theta J which is basically known as a bias function. In mathematical term, if you see, this is what that bias function does. Now if you consider this one, this F is known as the activation function. Now, if you see this part, summation of weighted function of Ji, you can see this is basically a linear function. You are multiplying some scalar quantity with the inputs, then you are adding this up, right? Now, whenever you are, see, what was our basic motivation behind using this neural network in the first place? We were trying to model the input-output relationship of a complicated physical phenomenon which cannot be modeled by a simple mathematical expression in the first place. So if you simply add up the weighted function of the inputs, you cannot expect the output to correlate with that complex phenomenon. So to incorporate that complexity in the analysis, we need to incorporate something non-linear. Okay? So that non-linearity is taken care of by this F, which is known as the activation function. Now this activation function is shown over here. So this is the neuron output and this is the shape of the activation function that we have. Okay? And by the way, this kind of a function is known as a sigmoidal function. Remember, this function is a non-linear function, but it still has a particular expression associated with it. Now, depending on what this bias function looks like or threshold function looks like, the shape of the output is going to vary like this. So essentially, you have a coming from here, and if the input is on this side, after some point it will saturate, it will also saturate on this side. So essentially, depending on, this is the active function that we have, this is the sigmoidal function. Shape modifier, this one, theta 0, theta 1, so on and so forth. So essentially, it will basically vary the slope of it. Now, why do we select activation function like this? There is a distinct mathematical advantage behind it. Now, if you consider if you consider how a neural network is trained, then the advantage of using a sigmoidal function as an activation function will be apparent. Now see, now I am assuming that you know the basic concept and the layering process of a neural network. So you have several layers like this, arranged like this, and you will have several neurons present over here. Now, neural network or artificial neural network is a part of supervisory learning network. That means you will have some input and you have output, and you know the value of input and the output, and that is how you train the weights of the neurons, right? Now, the training process basically incorporates something called bracket propagation algorithm. You see the output that you are getting from here, you calculate the difference between the expected output and the output that is given by the network, and you use that difference to calculate an error, and you calculate how much should be the modification in weights that are associated with each of these lines. Now this modification happens first over here, then it goes over here, and then it goes over here. Now if you see the mathematical part of it, you will see that there are several derivative functions associated over there. And this is where the activation function's mathematical expression comes into the play. Its derivation will be in the form of its original expression because it contains exponential functions. So as I was telling you earlier, that if you are considering a neural network or any kind of a network for that matter, you can have two types of learning processes. One is supervisory learning. That means for the training purpose of the network, you will have both inputs and the expected output. And you can also have unsupervised learning. Unsupervised learning, as the name suggests, you will have certain inputs, but the output will not be mentioned for training purposes. Okay? Please remember, both of these training as well as the networks involved, they are actually inspired from real life biological processes. Okay? So we will be taking, we will be discussing examples of each of the application of supervisory as well as unsupervisory learning methods. Now, if you are considering supervisory learning network, these are all the, what should I say, certain mathematical aspect that needs to be taken care of if you want a neural network to perform according to your requirements. Okay? Let's take an example where you have several variables, right? Now, first and foremost thing that you must remember is that you can have n number of independent variables on which your function is depending on. Okay? All of you are from electrical background, so let me give you an example.